Hello everyone, welcome to this video. In this video, we will dive into comparison of large samples covering essential statistical techniques for analyzing large sample data. Firstly, I am Kaushik, currently a second year student at SVCE. Let's start with what defines a large sample. In statistics, sample size matters especially when we are aiming for accuracy. Typically, n greater than 30 is a threshold for what we call a large sample for. But some scenarios require n greater than 50 or n greater than 100 for even better precision. Large samples allow us to make more reliable predictions about the population. For example, they reduce the margin of error, meaning our estimates are closer to the true values. This concept also connects the central limit theorem, a key principle in statistics, which also tells us that the means of the large samples will approximate a normal distribution, making our data easier to analyze with various statistical tests. Large samples are essentials in the fields like healthcare for clinical trials where precision can impact treatment effectiveness. In market research, where undergoing the understanding consumer behavior accurately drives business strategies, and in social sciences where large datasets helps in shape policies. Why do we compare large samples? Primarily to identify any differences or similarities between the group, which helps us to make better decisions. We often use hypothesis testing to explore these differences, allowing to validate specific research questions. For example, in healthcare, comparing true treatments, and in business, analyzing the customer satisfaction across demographics, and in education, evaluating different teaching methods in schools. Now let's discuss the major statistical tests used in large sample comparison. The first one is z-test, useful for comparing two means when we know the population variances or when the sample size is large. And the second one is t-test for the independent samples, ideal when variances are unknown and for large samples and as the t-distribution approaches the normal distribution as sample size increases. And the third one is chi-square test, helps determine the relationship between the categorical variables often used in survey data analysis or categorical consumer behavior analysis. And the last one is ANOVA. ANOVA is nothing but analysis of variances. Analyzes variance between multiple groups. This is especially helpful in experiments or studies with more than two groups. Each test is powerful in large sample settings due to increased power, meaning a better chance for detecting true effects if they exist, and they are less sensitive to normal assumptions, making them versatile. The Z-test for large samples. The Z-test is used when we need to compare two large samples to see if there is a significant difference in their means. This test is powerful because with large samples, the sampling distribution is normal, allowing us to use the Z-test effectively. When we use the Z-test, when sample size is large, that is n greater than 30, and the population variances are known or assumed to be equal. The formula is simple. It's the difference between the sample means divided by the combined standard errors for the samples. For instance, if we wanted to know if the average height difference between the two countries, we would use the Z-test to statistically analyze the difference. And let's look into the assumptions. The data should be distributed or the sample size should be large enough to meet the condition central limit theorem applies, and samples should be independent of each other. T-test for independent samples in large samples. The t-test is bit more flexible since it doesn't require knowledge of population variances, making it ideal when only sample data is available. When we use the t-test, this test is used for large sample sizes where we don't know the population variances. In large samples, the t-distribution approaches the normal distribution, which strengthens the accuracy of the test. And the formula is same as the z-test, but here we substitute the sample variances. And the assumptions are random sampling, independent samples, and similar variances across groups. As an example, could be comparing the test scores between the two classrooms to evaluate if different teaching methods are more statistically significant difference. Chi-square test for large samples. The chi-square test is more powerful for categorical data analysis. It helps us to understand if two variables are related. For example, if customer satisfaction differs across different age groups. The formula. This test compares observed frequencies against expected frequencies with large deviations indicating potential relationships between variables. When to use? Anytime you need to test associations between categorical variables. In our example of customer satisfaction by age, if the observed satisfaction levels significantly differ from expected ones, this suggests a relationship between age and satisfaction levels. And the assumptions are a large enough sample size to ensure accuracy in expected frequencies and independent observations. ANOVA analysis of variance in large samples. Purpose to test the differences among the two group means. ANOVA extends beyond two groups, letting us compare multiple group means to see if there is a statistically significant difference among them. And the formula. ANOVA calculates an F ratio by comparing the variability between groups to variability within groups, with a higher F indicating more significant difference. There is two types of ANOVA, one-way ANOVA and two-way ANOVA. For a single independent variable, like comparing exam scores across multiple classes, and the two-way ANOVA indicates adds a second variable such as gender in addition to class to see how both factors impact scores. And the assumptions. Independent samples, normal distribution of groups, and equal variances. ANOVA is especially useful for fields like education or psychology, where we are often comparing multiple groups to understand complex relationships. Central limit theorem in large samples. Finally, the central limit theorem is a foundational of large sample testing. The CLT states that the sample size grows, the distribution of the sample means will approximate a normal distribution. This allows us to use parametric tests like z-test, f-set, and t-test, which rely on the normal distribution. Why CLT matters? The central limit theorem makes it possible to apply these tests even on data that isn't perfectly normal, as long as our sample size is large. For instance, if we take large enough sample of people heights, their average height will tend to be normally distributed regardless of the population distribution. And the key takeaways. Central limit theorem is the reason why many of the methods we have discussed work well with large sample means, even if the data is not perfectly normal. And the central limit theorem is foundational for large sample hypothesis testing. Now let's look into the summary and conclusion. To summarize, comparing large samples is key for reliable analysis and accurate data insights. And the main techniques include z-test, t-test, chi-square test, and ANOVA, which is suited to different types of data. And the central limit theorem also allows us to use the parametric test confidently with large samples, ensuring normality in sample means. And finally, concluding that effective large samples comparisons empower informed decision making across fields like healthcare, business, and education, transforming data into meaningful insights.